YouTube. It's Kate again from Kate in the City. I wanted to do a little bit something different today. I wanted to talk about another YouTube video that I watched that is from Mind Your Decisions, which I really like his video. If you like mathematics, you'll love his videos. And it was this question here, and it was given to I believe it was 4th grade students in China, and what is the area that is shaded in red? And I actually got the same or a similar answer than Mind Your Decisions did. However, I went towards it in a little bit different manner, which I think maybe is a little bit easier. I'm not sure, I guess it's whatever you're more comfortable with, but I wanted to kind of go over this. So what we have is we have a rectangle that is dimensions 20 by 10. Inside it, it has 2 circles and is split diagonally from the top left corner to the top or to the bottom right corner. Now, if you take a look, your first impression is that, oh, well, it is half of a triangle that we're looking for the red parts in, and this is true. However, you don't have this red part here, which would be, if you were to solve for this whole triangle, the easiest to do, but this makes it a little harder by taking out this piece here. All right, so let's just go ahead and start by finding the dimensions of the whole triangle that includes these pieces of the circle and this missing piece. So the formula for a triangle is 1/2 base times its height. All right, so what this would be is it would be 1/2 20 times 10. All right, so that would be 200 divided by 2, which equals 100, which of course that is because 1/2 times 200. So if you're going to multiply a denominator, then it's actually divides because it's over 1. Okay, so 200 divided by 2 equals 100. Okay, so let's go ahead and kind of just erase our board and now take a look. Now we just found the area of one of these 2 triangles, okay? And we're going to focus on this one because this is what it's asking us, is where the red, or what the area of the shaded red, okay? So now we need to get rid of these circles, right? Because this is not shaded red in the triangle. So if you take a look, you have this portion of the circle and this portion of the circle. And if you would take a mirror image and flip this triangle, you would see that it is the exact same. So what that means is that this part of the circle and this part of the circle equals 1 circle. All right, so let's go ahead and find the area of that. And the formula for finding a circle is pi r squared. All right, so Mind Your Decisions went to 3 significant figures after the decimal point, and so that's what I'm going to continue with as well. Mine is slightly different answer just because of rounding. So we get back to this, pi we'll say is 3.141 with 3 significant figures after the decimal, a total of 4, times, and our r, okay, so r is this middle point to the end, or to any end, right, because a circle is going to be the same distance. All right, so we know from here to here is 10, so half of that we know is 5. So this is going to be 5 squared. Okay, so this is really 3.141 times 25. All right, and what that comes out to is 78.525. Sorry, I kind of ran out of room there. All right, now we got to stop and look at what this 78.525 is giving us, okay? Now, we just said we found the area of one circle. Okay, so if we draw this again, very crudely, circles are my worst, sorry guys. Well, then this is giving us this part of the circle and this part of the circle. Okay, so we've taken those out. Now, the only thing that we're missing now is this little piece up in the corner, okay? And we need to figure out how much that is. And this is where Mind Your Decisions and I have kind of varied from how we confronted this problem. So let me go ahead and erase the whiteboard and we will continue from there. So now we have found the area of this whole triangle, which is 100, and we found the area of one of these circles, which is 78.525. Okay, now we want to take these circles out of it, okay, out of the whole triangle, because we don't need those. They're not shaded in red. Okay, so we would take the 100 minus the 75.525, all right, and that comes out to 21.475. Okay, now what this is this triangle with this part of the circle cut out and this part of the circle cut out. All right, so it's this one, this part in the middle, and this part. Excuse my horrible drawing. All right, now how does this picture differ from this picture as far as the red parts are going? It's because this part's not shaded in red, right? All right, so that means that we need to get rid of this part. Okay, we got rid of the circle, now we got to get rid of this part. And this is where I looked at this in a little bit different way. I didn't use any type of trig functions. All right, so let's go ahead and erase this and we'll go from there. Okay, so kind of to expound on this thought, what this means is that we found the whole area of this triangle minus one circle. All right, and now if you think about it, and that includes here, the area that is under this triangle minus the circle would be the same area as one square, okay, minus the circle. So that gives us a lot of information. It means that we now know that each one of these corners in a square have to be the same area. Okay, so we know the total area, which is 21.475, and since there's 4 corners in every square and they're all the same, we know that we can divide by 4 and we can get the area of one corner. All right, and so that would end up coming out to 5.369. All right, so if we take a look now, that means that if we look at it in a square point of view, we know one full corner is 5.369. Okay, so now let's take a look in here and sort of, you can just kind of visualize how many corners you would have. You would have one here, okay? Now this is split down the middle, right? We're only looking at this half of the picture. So, but we do have this corner fully filled in. All right, we also have another corner on this half of the square. We can actually move it up here. So we have this one filled in. And this is where our picture does not have the part filled in. So this goes from the center right to the corner. And we have this part filled in. And we still are looking for this one. All right, but we know that this has 5.369. This has 5.369. This has 5.369. And so if we took this and multiplied it by 3, we would get 16.017. Okay, so now we know what all of this and this is. All right, so 16.017, that means that we have a difference of 5.369 in these two parts to find. Okay, now to think about this logically, you will notice when you look at this full picture that this rectangle is twice as long as it is high, right? So you can say that's a 2-to-1 ratio or a 1-to-2 ratio. It's both the same. But what that does is that means that there's a total of 3 lengths in all. All right, so we have 1 length to 10, 2 lengths to 10, and you can do 1 length up. All right, and that's just a proportion. Okay, there's always going to be twice as long as it is high. What that means is that it holds true when you put this diagonal here. Okay, that there's from corner to corner, because this is the hypotenuse, you know that since this is twice over a total of 3 times, that this part shaded in here that I just ruined is going to be 2 out of 3 parts of that one corner. Okay, this part that we do not want is going to be 1/3. And that's really the last piece of information that you need. Okay, because if you think about this, you have 3 corners, all right, which is 5.369 times 3, which equals 6.017. All right, and then you know that you need another 2/3 out of a whole one of the corners. Okay, so 5.369 times 2/3, which is actually, I know this is it's 7 6s and a 7. I don't know how I remember that. It's just easy. So 1, 2, 3, 4, 5, 6, 7, and a 7. All right, if you punch this into your calculator, which I wouldn't say do this by hand, you would get that this equals 3.579. All right, 3.579 is how much this one is an area of. Okay, so we know that we have 3 total corners, which is the 6.017, and we have a partial corner that is 3.579. All right, let me erase my board and I will show you the answer. All right, so if we have that 16.017 and we add it to the 3.579, it gives us a total of these areas without this as 19.686. All right, now if you watch the other video from Mind Your Decisions, which I will put in a link down below, which I very much encourage you to do, our numbers differ. I think that, I don't remember his exact number, but I think that it's about 1/10 of a difference. And the reasoning for this is significant figures. Okay, when you're using trigonometry to find numbers, it's a much more exact mathematics. Okay, and I think that that's why he did it this way. However, without knowing any type of trigonometry, you can go ahead and still get the correct answer to about 1/10. And just to show you this, if you did this whole mathematics problem over again and only used one significant figure instead of, I'm sorry, one significant figure after the decimal, then you would see the difference, because it would equal to 19.8. Okay, and you can see with the difference of two significant figures after the decimal, you get a difference of about 2/10, which is still pretty close. You know, you guys, I would love to hear what you have to say about this, what you think. And if you happen to get this question right, if you like this video, please hit like down below. Please make sure you subscribe, and most of all, share.